Questions 11 through 20 on the 2014 Grade 12 AMC 12A. David drives from his home to the airport to catch a flight. He drives 35 miles in the first hour, but realizes that he will be 1 hour late if he continues at this speed. He increases his speed by 15 miles per hour for the rest of the way to the airport and arrives 30 minutes early. How many miles is the airport from his home? Well, he is going from one point to another point, home to the airport. And the first, say, 1 hour or so, I don't know exactly where it is, but let's just say from that point to that point, it's 35 miles per hour that he drives at, and he does that for 1 hour, so obviously he's covering 35 miles. And we're going to use the formula speed is equal to distance over time. So from that first piece of information, we are told that if he continues to drive at 35 miles per hour, he'll be 1 hour late. So if that total distance we denote as d, he will arrive t plus 1, where t is the time it takes him to get to the airport just in time. He's going to arrive one more hour than that if he drives at 35. So what he does is he increases his speed to 50. And he drives 50 miles per hour for the remaining distance, which is d minus 35, the distance minus 35 miles. And with that piece of information, we are told that when the speed is 50 and the distance is d minus 35, he actually arrives half an hour early. So he's already driven 1 hour, so from the time he's already driven 1, so we have to subtract the 1, and then you have to subtract another half because he's a half an hour early. So we have two equations, two variables, and we can easily solve. So from the first one, we get 35 times t plus 1 is equal to d. Second equation, we get 50 times t minus 3 over 2 is equal to d minus 35. And if we put the 35 on the other side, like that, we can get rid of it from this side. And there we go. We got d is equal to two different things, so set them equal to each other. So 35 t, let's multiply them out, plus 35 is equal to 35 plus 50t minus 75. So this becomes 15t is equal to 75, and therefore t is equal to 5. Substitute that back into either one of these, and we will get the value for d. d will be equal to 35 times 5 plus 1, and that is 35 times 6, which is 210. So the distance from his home to the airport is 210. The answer to number 11 is C. Two circles intersect at points A and B. The minor arcs AB measure 30 and 60. What is the ratio of the area of the larger circle to the area of the smaller circle? All right, so let's draw the diagram first. Let's say we have one circle like that and another circle like this, approximately. And then what they're saying is that if you were to measure the angles from the center of the circle to the arc like that, they've given us two angles. One is 60 and one is 30. And they want you to eventually figure out the ratio of the area of the larger circle, which would be pi r squared, to the area of the smaller circle, pi small r squared. Since the pi's cancel, really all we have to do is figure out big R squared over small r squared. All right, so how do we do this? Let's connect the A and B. So those 2 points, this point right here is A, and this point right here is B. And let's connect them like that. So it's not perfectly drawn to scale, but I hope you will be able to figure out that this now is equilateral. And the reason is because from here to here, the center, let's say we call it O, to there is the radius. And the center from here is also the radius. So that means that this angle must be the same as that angle. Now, since this angle is already 60, those two angles add up to 120, so each of them is 60. So that's 60 and that's 60. So since it's equilateral, that red line is also equal to r. And there we go. And then what I'm going to do is this triangle right here, I'm going to draw it a little bit bigger on the side here to make it easier to understand. So that triangle I'm going to draw like that and label it exactly the same. So this is 30 degrees and this is r. And now we have to figure out the distance from here to here, which is big R, like that. And this is also big R. So this is big R and big R. Well, at this point, a few ways to proceed. I'm just going to use the law of cosines. It seems like the easiest way to do it. Law of cosines. It's set up in such an obvious way. So that means small r squared will be big R squared plus big R squared minus 2 times r cos 30. So small r squared, 2r squared minus 2r squared. Cos of 30 is what, root 3 over 2? Yeah, root 3 over 2. So now we have r squared, factor out the big R squared, and we get 2 minus root 3. Yeah. Okay, let's just put it in that form. Might as well. So r squared over small r squared will be equivalent to 1 over 2 minus root 3. And that's the answer. But obviously it doesn't look like any of the answer choices, and that's pretty easy to understand why, because they just rationalize the denominator. So multiply top and bottom by 2 plus root 3, the conjugate, and you get 2 plus root 3. And on the bottom, you get 4 minus 3, which is just 1. So there we go, 2 plus root 3. And therefore, the answer is D for number 12. A fancy bed and breakfast inn has 5 rooms, each with a distinctive color-coded decor. One day, 5 friends arrive to spend the night. There are no other guests that night. The friends can room in any combination they wish, but no more than 2 friends per room. In how many ways can the innkeeper assign the guests to the rooms? We have 5 rooms. 1, 2, 3, 4, 5. Room 1, room 2, room 3, and room 4 and 5. Now, there's a few ways, right? The first way is if you just have 1 friend in each room like that. That's pretty straightforward. 5 choices for the first room, 5 friends, so one of those 5. Then 4 choices for the second room, 3 choices, 2 choices, then 1. So that's pretty straightforward. That gives you 120. The other way of doing it is 2 in one room, 2 friends in one room, and then 1, 1, 1, like that. So let's talk about this one now. So from the 5 friends, we have to choose 2. These 2 that are going to be in the same room. And then from the 5 rooms, we have to choose 1 to place those 2 friends in. All right. And then from the remaining 4 rooms, we have to choose 3 for these 3 friends. And then in those 3 rooms, we can place the 3 friends as follows. 3 friends for the first room we can choose from. Then we can choose from 2 friends for the second room, and then 1 friend for the last room. So that is why we put this 3 times 2 times 1, like that. So 5 choose 2 is 10. 5 choose 1 is 5. 4 choose 3 is 4. And then 3 times 2 times 1 is 6. And that gives me 50 times 24, which is 1,200. Okay, so So far, so good. Now we have one final scenario, which is you put two friends in one room, two friends in another room, and one friend in alone by himself or herself. Okay, so let's talk about this now. This is a bit trickier. So from the 5 rooms, we have to choose 2 rooms. And those 2 rooms are for these guys. This couple and this couple. Okay? Then from the remaining 3 rooms, we choose 1 room for this guy. So that takes care of the rooms. Now we have to assign the friends. From the 5 friends, we have to choose 1 friend. That's going to be the guy who rooms alone. And then from the remaining 4 friends, we have to choose 2 that are going to be those guys. And then from the remaining 2 friends, we choose 2 friends that are going to be these guys. And that is the math for this scenario. This is 10, this is 3, this is 5, 4 choose 2 is 6, and 2 choose 2 is 1. So 10 times 3 times 5 times 6 is 900. So now we add up this, and this, and when you do, you get a total of 2220. And therefore, number 13, the answer is B. Let A be less than B, less than C, be 3 integers, such that A, B, and C is an arithmetic progression, and a CB is a geometric progression. What is the smallest possible value for C? Well, we have some very important parameters that A, B, and C are in that inequality. So therefore, it's increasing. This is an increasing arithmetic progression. And A, B, and C, because it's arithmetic, are of the form A plus D, and A plus 2D, like that. And then they told me that ACB is a geometric progression. So that's AR squared. Okay, so that's the first thing. All right, so now using this, we know that if I take AR and divide it by A, it's the same as AR squared divided by AR, because both of these are equivalent to just R. So based on R letters up here, that's C over A is equal to B over C. Cross multiply and you get C squared is equal to AB. Okay, so now we take this piece of information and apply these values. So C is A plus 2D, so it would be A plus 2D squared is equal to A times B. A is this and B is that. So it would be A times A plus D, like that. All right, so now let's expand this out and simplify as much as we can. So this is A squared plus 4AD plus 4D squared is equal to A squared plus AD. And putting everything on one side, 3AD plus 4D squared is equal to 0. Okay. Well, at this point, we have to do a little bit of thinking here. The first thing, of course, is because this is increasing, D must be greater than 0. That's the first thing. That's a kind of common sense, I think. And that's because A is less than B is less than C, like that. And then we can divide through by D here, since D is greater than 0. So that will just leave me with 3A plus 4D is equal to 0. And isolating for A, we get minus 4D over 3. All right. So at this point, you say, okay, that's great. So far, I've completely understood all of this, but where do I go from here? Well, remember, we are interested in finding the value for C. Well, C is A plus 2D. Okay, so let's substitute that in. A plus 2D would be minus 4D over 3 plus 2D. Correct? Get a common denominator, and we get C is equal to 6 minus 4, so 2D over 3. Now, in the beginning of the question, they told you that a, b, and c are integers. So this must be some integer. And how do we get it to be an integer? Well, if d is 3, it would be an integer, right? If d is set to 3, if the difference is 3, then c would just become 2. But before we circle 2 as the answer, let's verify if this actually works out. If c is 2 and d is 3, then what are my values for these guys right here? Let's figure that out. Well, a becomes minus 4d over 3. Well, d is 3, so this becomes minus 4. b is a plus d. Well, that's going to be negative 1. And then c, well, we figured out already, is 2. Does this satisfy that inequality? And sure, it does. Over on this side, the geometric progression, a is negative 4, c is 2, and b is negative 1. So r is 2 over negative 4, which is essentially negative a half. So this works out. So the answer is 2 for c, and therefore number 14, it's choice C. A 5-digit palindrome is a positive integer with respective digits a, b, c, b, a, where a is not 0. Let s be the sum of all 5-digit palindromes. What is the sum of the digits of s? All right, well, there's a little bit of a shortcut I can show you, and shortcuts are always valuable on math contests since you don't have that much time. Let's say I list the very smallest palindrome under the conditions and the very largest one, 9999. Well, what is the sum of those two guys? Well, the sum is 10001 plus 99999, and that is equal to 110000. Okay, now let's put the second smallest, which is 10101, and the second largest, which is 99899. What's the sum there of those two guys? Well, 10101 plus 99899, and that sum is 110000. Same thing. Let's do one more, just to convince you. The third smallest, I guess, and the third largest, so 99799. Let's get the sum there. And that, as I'm sure you probably predicted, is the same. So that means that all these sums are the same. So if we're adding all of them from very smallest to the very largest, each pair will have a sum of that. So we have to first figure out how many are there, and then we can divide by 2 to figure out how many pairs there are. Or the total number of palindromes we can figure out by something they really just gave us, this right here. All of them are of the form A, B, C, B, A. Well, for A, how many choices do I have? I can't put a 0, but I can put anything from 1 to 9. So I've got 9 choices. And whatever I put for there, I have to put here. So there's only one choice there. It's the same number. B, well, B can be anything from 0 to 9. So I got 10 choices for B. Whatever I put for B, I have to put the same thing there. So I'm fixed with the second value. For C, I can put any number from 0 to 9. So again, 10 choices. So this is the total number of palindromes, and that is 900. Well, I'm adding pairs, right? All these were pairs. So if there's 900 palindromes, how many pairs are there? Well, 900 divided by 2, which is 450 pairs. And each pair has a value of 110000. So the total sum will be 450 times 110000, and that is equal to 49,500,000. That is my S. They want you to now find the sum of the digits of S. Okay, the sum of the digits of S is not a problem. 4 plus 9 plus 5. And the zeros don't contribute to the sum, and that is 18. So number 15, the answer is B. The product 8 times 888 dot 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 8, where the second factor has k digits, is an integer whose digits have a sum of 1000. What is k? Well, let's figure out what happens for small values of k, and then we can extrapolate the decision that we make, or the pattern that we find. So when k is 2, basically we just have two k's, or two 8s rather, right here. K is equal to 2. So let's figure this out. This is obviously 8 times 8 times 11, and the product is 704. Now the sum of these digits is 11. So I'll just put that out there. Now when k is 2, we have 8 times 8, 8, 8, and that is of course 8 times 8 times 111, and that product is 7104. The sum of these digits is 12. That's for k equals 3, sorry. When k is 4, we have 8 times 8, 8, 8, 8, like that. And this is 8 times 8 times 1111. And this is 71104, and that sum is 13. I'll do one more. When k is 5, you're getting the hang of this, hopefully. 8, 8, 8, 5 times. And then that's 8 times 8 times 11111, and that is 71104, and that sum is 14. So in general, it seems like the sum and the k's are related as follows. The sum minus the value of k looks like it's always 9. And if you see, so far, that holds true for the 4 examples I gave. And I'm pretty sure it always holds true. So they want a sum of 1,000. Okay, put 1,000 there. And they want you to figure out what is k when the sum is 1,000. Well, it's pretty easy. Subtract 9, and that's going to be the value for k, which is 991. So it's a cool little question. Number 16, the answer is D. A 4x4x8 rectangular box contains a sphere of radius 2 and 8 smaller spheres of radius 1. The smaller spheres are tangent to the 3 sides of the box, and the larger sphere is tangent to each of the smaller spheres. What is H? Well, we have a scenario as follows. If we draw lines like that, let's label them. The small sphere have a radius of 1, so that is going to be 1 right there. And 1 similarly down there. Now this diagonal is going from the center of the small sphere to the center of the large sphere. And we know that if you're going to do that, it's going to be 1 here and 2 there. So that's going to be a total of 3. And similarly, 2 and 1. Now this is in 3D, so this is not in 2D. So that's one of the challenging parts. But I can draw it hopefully in a way that you can understand it. Now, if I draw a line straight down like this, then I draw a line from there to there. And that is the triangle that's going to help me. That's going to help me figure out the distance. And the top to bottom distance I'm really referring to is this right here. From here to here. That is what I'm interested in. And that I will call anything. Let's just call it Y. And then of course I also have to figure out this distance, which I will call X. And then this distance from there to there I had already written. It was 3. So Y, X, and 3, right? So that is going to help me figure out H. H, of course, is the distance from top to bottom there. And H is this one right here, plus the distance from here to here, which is basically going to be Y, because what we do in this part, this bottom half is identical to the top half. And then the bottom half I've already labeled Y, that vertical distance. And then at the very bottom, there'll be another 1 adding to the vertical distance. So h will basically be 2 plus 2y. If I can calculate y, I'm done with the question. Okay, so first and foremost, I have to figure out x in that triangle. Once I figure out x, then I can figure out y using Pythagoras. Okay, so what is x, by the way? To illustrate what x is, I'm going to draw sort of the base of this in a way so that it's a bird's eye view. Actually, maybe looking at it from the bottom. So here we go. This is basically looking at the bottom of this rectangular box, and these circles represent the 4 small spheres. X right here is basically the distance from the center of one of them to the center of the box. So it's from here to here. That is what x is. So let's draw that in. So just to recap, if this red dot here is the center of that small sphere, x is basically the distance from there, to the center of the box, basically. So all we really have to do is calculate the diagonal and then chop it in half. And that can be easily done. The box is 4 by 4, so this is going to be 2, and this is going to be 2. So we've got 2, 2, and of course x and x. So here we go, using Pythagoras, I can easily figure that out. 2x squared is equal to 2 squared plus 2 squared. So 4x squared is equal to 4 plus 4, which is 8. X squared is equal to 2. X is root 2. There we go. Now I can go back and figure out y. So x squared plus y squared is equal to 3 squared. So x squared is 2, y squared is what I'm trying to figure out, and that's 9. So y squared is 7, y is root 7. Now I can go back and very quickly figure out what is h. It's 2 plus 2 root 7. And that's it. So number 17, the answer is A. The domain of the function f at x is equal to this big long expression is an interval of length m over n, where m and n are relatively prime positive integers. What is m plus n? Well, let's write out this big long expression. So 1/2, and then we have the log of 4, then the log of a quarter, then the log of a 16 I should say, and then the log of 1 over 16, and then x, and then we have 4 brackets, 1, 2, 3, 4. Okay, so let's first do this in steps to make it as understandable as possible. I'm going to call this A, not the whole thing, just that part. Now we know that, therefore, if we have anything called the log of something, in our case, it's the log of A has to be greater than 0. You can't take the log of a negative number. You can't take the log of 0 either. Try it in a calculator, it says error. So that conclusion that we make is that this big expression that I've called A is greater than 0. Greater than 0. Okay? So no tricks, just basic log rules. Now we get to the next part. In a very similar way, I am going to call just this part of the equation b. So now we have the log of b to the base 4. And we know that according to what we have concluded, that's got to be greater than 0, right? And if that is 0, that means that b must be greater than 1, based on basic log rules. And if you're not sure about that, go back and review your log rules. It's basically the fundamentals of logarithms. So that means we have to now conclude that this whole thing that I've called b is greater than 1. So we are now moving right along, and we get to the next step. Now the next step, I'm now going to call this part c. And therefore, that means the log of c to the base 1/4 is greater than 1, according to what we have written there. The only way that's true is if c is between 1/4 and 0. And that's entirely based on log rules. So, therefore, now we've got our next expression. That expression is between 0 and 1/4 that I had called c. Moving along in the same sort of way, let's call this guy in here d. So that means that the log of d to the base 16 is between 1/4 and 0. And the only way that would be true is if d was between 16 to the power of a fourth and between 16 to the power of 0, like that. And that is basically 1 and 2. All right, so that definitely helps us out. So now we're in I believe the final step, that the log of x to the 1/16 is between 2 and 1. All right, so let's move this up a bit. So this is 1/16, sorry. So now from this inequality, we can get to our final conclusion that x is between 1/16 to the power of 1 and 1/16 to the power of 2. And that basically means that x is between 1/16 and 1/256. So that range, that interval that they're talking about, is basically from between 1/16 and 1/256. And if you do that math, you get 15/256. And this is what they're calling m/n. And therefore m plus n is 15 plus 256, which is 271. And that is the answer to number 18, choice C. There are exactly n distinct rational numbers k such that the absolute value of k is less than 200, and 5x squared plus kx plus 12 is equal to 0. Has at least one integer solution for x. What is n? 5x squared plus kx plus 12 is equal to 0. Let's try to isolate just for k. So kx is equal to minus 12 minus 5x squared. Therefore k, if you divide through by x, will be 12 over x minus 5x, like that. And this is what we will work with. Now keep in mind that k has a range. It's anywhere between 200 and negative 200, since its absolute value is less than 200. So let's put this value that I just figured out in that range. So minus 200 is less than minus 12 over x minus 5x is less than 200. And I'm interested in getting a range for x. Okay, it's not as simple to get a range for x. Like, what is x between? If minus 12 over x minus 5x is between negative 200 and 200, what is x between? That is what I'm interested in. That's going to give me an idea of how many values of k there are. Well, how do I do that? It's a little bit challenging, not straightforward. So what I'll do is I'll just calculate it for the upper limit. So minus 12 over x minus 5x, let's just say it's 200. And that will give me sort of an approximation of what this range will be. Okay, let's do this math here. So let's put everything on, multiply through by x, and you get minus 12 minus 5x squared is equal to 200x. Put everything on one side, and we get 5x squared plus 200x plus 12 is equal to 0. We have to use a quadratic, and when we do, we get minus 200 plus or minus the square root of 200 squared minus 4 times 5 times 12 all over 2 times 5. And when you crunch out these numbers, you get about minus 39.9. And there's one other root, but this is the one that's going to help us. So that means that it's going to be less than minus 39.9. So since x are integers, right, integer solutions, that means minus 39 is going to be that integer on that end of the spectrum. And on this end of the spectrum, it'll be plus 39, which is the value I'd most likely get when I substitute minus 200 in this equation. Okay, so that's a pretty good range. And then how many are there? Minus 39 to 39. That's 39 plus the 0. But when x is 0, this equation will not give any solutions. Try it. You'll see that 12 is equal 0. So we can only include the 39 on the negative side and the 39 on the positive side, and that'll give me 78 values for x. And for each of those values of x, there's a corresponding value for k, right? Whatever you put for x, it will give you one value for k. And they're asking for how many values of k, because n represents the number of values of k. Well, there's 78 values for x, and there will be 78 values for k. So that is the answer to number 19, and that is choice E. In triangle BAC, angle BAC is 40, AB is 10, AC is 6. Points D and E lie on AB and AC respectively. What is the minimum possible value for BE plus DE plus CD? Here's an excellent diagram that helps tremendously with the question. We have triangle BAC right here, BAC. And what we have done in this diagram is as follows. Reflect C across AB. So here's C. Reflect it across AB, treating AB like, sort of like a mirror, and you get to this C dash. Okay, so basically what we did was we said, okay, AB is like a mirror reflection, so we're going to go straight over that way. And that's why, since this is 40, this is also 40, because it was exactly a mirror reflection, 40 degrees on this side, 40 degrees on that side. Then we're going to do another reflection, reflect B across AC. So here's B. Again, we're going to treat AC sort of like a mirror reflection, and we're going to take B and reflect it over there to give you B dash. And very similarly, since that's 40, that's going to be 40. 40 on this side, 40 on that side, degrees. And now you will see that the distance BE, which is from here to here, will be the same as the distance from B dash to E, which is the distance from here to here. And also CD, which is the distance from here to there, will be the same as the distance from C dash to D, which is from there to there. So what they're asking for, which was BE plus DE plus CD, is equivalent to B dash E plus DE plus C dash D. So B dash E is the distance from here to here, DE is here, and C dash D is here. And as you can see, that is minimized when all of those are on the same line. And that is known as being collinear. So now to figure out the distance from there to there, we just use the cosine law on this big triangle right there. So that distance is really equivalent to writing C dash B dash, the distance from here to here, which is equivalent to these guys, which is what the question wants. And that's going to be 6 squared plus 10 squared minus 2 times 6 times 10 times the cos of this whole angle, which is 120. And since I'm not interested in CB squared, I just want CB, I've got to take the square root of all of that. So that's going to be 36 plus 100 minus 120 times negative 0.5. And that is 136 plus 60, which is 196. And the square root of 196 is 14. So 14 is the minimum value for BE plus DE plus CD, and therefore number 20, the answer is D.